All right, my name is Jim Davis. I work with Fluke Networks, and today we're going to talk about how we can test our installed cabling to make sure that it's ready for today's and for tomorrow's Power over Ethernet. We're going to be using this as our piece of cable for today, and we're going to be running tests with our Versiv 2 unit. You're going to be able to see over there what's happening on the tester, so as I push buttons on the tester, you'll see the screen change. Real quickly, today we're going to be working with the Fluke Networks Versiv 2 tester, and this is a modular tester. We can attach different modules. Today we're going to be using our DSX 8000 copper module, but we could also be using the CertiFiber Pro light source and power meter for fiber optic tests. We find that installers who install data cabling often install fiber optic cable as well, or you could use one of our OTDR modules to find the distance to where a problem is. And just that easily, we have an OTDR. Now, a question came up about the 8000 module offline from last week that I wanted to touch on real quickly. Here, we have the measurement port, and this is where we're actually going to be making the measurement. Very often, we'll use a channel module to attach here to run our channel tests, or we could use a permanent link adapter like we're going to be doing in our tests. But the question that I got was, what is this port over here? This port we use for doing alien crosstalk testing, and it's just communication from the main to the remote unit. Of course, this is the main and this is the remote. I get myself discombobulated. All right, so today, first thing we're going to do is run a test. We're going to be running a category 5E permanent link test on an unshielded twisted pair cable. And I want to start with this because we always promote the standard and we want to guide people with the right way to get things done. But there is a challenge with the standard when it comes to the basic testing for Power over Ethernet. And that's our favorite test result, resistance. And this letter I. What is going on with the letter I? Why am I getting a letter I? Well, the reason is, while the 568 standard defines the resistance values, the TIA 1152, currently on the A revision standard, tells us what tests we need to run and with what accuracy. And we are not required to run a resistance test. That's why there's no limit for this. We've measured it, but we do not apply pass-fail values. Now I'm going to go off on a quick tangent here because I'm sure many of you noticed this bright orange warning and the marginal pass. What's going on with our marginal pass? Well, we've passed insertion loss and we've passed next by quite a bit. The return loss here, 2.1 dB of margin. I'm going to just select the one pair. It's the 3/6 pair. And down here at just 13.8 megahertz, fairly low frequency, we see that the measured value is very close. That's a cursor. The measured value is close to the limit line. And the standard says that if we are close to the limit line, we need to advise you. Now, is this acceptable? Well, a pass is a pass. What does your cabling testing specification say? Does it allow for marginal passes? Conversation for another day. But our concern here is resistance. This is passed. We're good. You might want to be afraid of this cable. Now, while it is passed, it's not a complete test for Power over Ethernet. If I'm going to be doing a complete test for Power over Ethernet, let's set up a new test here in the tester. We're going to use the same 5E UTP cable, but in our test limit, we'll select More and TIA. We're testing 5E. And here you can see that we have the basic permanent link and channel test. We also have this plus all tests, which is a superset of the basic and the plus PoE, and we have the plus PoE tests. If we are planning to run PoE on our cabling, and why else are we installing copper? If we don't want to power something, we'd probably go wireless otherwise. We really want to use these plus PoE limits. This is the same cable. I haven't touched it. I haven't moved it. Now, curiously, this is going to fail when we run this plus PoE test. And the reason it's going to fail, please, maybe, it's definitely failing. Hey, oh, big sigh of relief. The reason it's failing, look, we're still passing return loss. We're still passing insertion loss. And next, important parameters for Ethernet. But for power, resistance is a very important value for us. If there's too much resistance, we're not going to get enough power out of the far end. The cable may overheat if the cable's in a bundle. That may cause problems for us if it's overheating. So what is this loop resistance that it's failed? Well, if we look at our single pair, we can see that the two legs and the loop resistance is the resistance of one leg added to the resistance of the other leg. Pair-to-pair unbalance, which this cable actually passes, is the difference between the resistance of one leg and the resistance of the other leg. So why is it that this cable is failing the resistance value? Well, I'm going to ask you to look at some really fine print here on the cable here. This might be a little bit hard to see, but they're saying it's category 5E, and they have this funny CCA written down here. CCA stands for copper-clad or copper-coated aluminum. What is copper-coated aluminum? Well, let's take a look here. Copper-coated aluminum is an interior conductor of aluminum wrapped with copper on the outside. And we might say, wow, that's interesting. Why would somebody
Jim, I don't think we can see. I think you're showing an image we can't see.
Oh, thanks for telling me that.
No problem.
Now are we getting it?
Not there yet.
All right, let's try one more time. Please share this image. Please share this image. Nope. Try pushing this button and see if it'll share it. Now is it sharing it?
It's sharing. There we go.
Oh, thank you. Okay.
Yeah, there it is.
So here we see the core of the conductor is aluminum and it's wrapped in copper. There are applications for this cable, but category 5E data cables are not one of them. The 568 standard and its international equivalent, the ISO 11801, clearly state that they shall be of pure bare copper. And our problem, or our question is, why would somebody use this cable? Well, there's a whole song and dance that someone will talk about skin effect, and the signal stays on the outside of the conductor, doesn't go to the inside, which may be true for high frequencies, but we're talking about power. The real reason
Hey, Jim, you've got something in front of your slide there. If you just move those windows over to the right, I think it'll be a lot easier to read.
All right. And
there
you're probably on the wrong view. You know, we ought to rehearse these more. So
more than we already do?
Anyways, a conversation for another day. Here's the reason why people are using aluminum instead of copper. Copper is about 3 times more expensive than aluminum. Let's get out of this goofy, unfortunate, not happy to be shared. That's why we don't use PowerPoint. It doesn't, stop sharing. Stop, go away, go away. So, how about those Cubs? All right, so we understand that this cable is inexpensive, and my big concern is when you're shopping for cable, you might look at the price of the cable and perhaps be deceived. Let's go online and look at a store where somebody might buy cable today. This is real. Let's see how this works for me. Let's look for category 5 cable. All right, so we look for our category 5 cable, and oh, look at this. Here we go. Fast Cat cable, and see, this is 1,000 feet, category 5E for $95. Oh, look at this next one. 1,000 feet, category 5E, 4 pairs, $42. I don't know about your boss, but boy, mine would say that is a really tempting price to look at. But let's look at the fine print here, and I will give them credit for their honesty and saying that this is copper-clad aluminum. This is not a category 5E cable. I don't need to test it. It doesn't meet the requirements, and I know that this is going to cause a problem with resistance, and it's not going to be able to support the high speed, or I'm sorry, the high power over Ethernet applications that I'm going to be looking at. So please be careful of these CCA cables. Now, what we want to use is a nice category 6A cable. Why are we going to use a Category 6A cable? Because we're only going faster with wireless. Anyone not going faster with wireless? Yeah, I thought everyone is saying I would take some more bandwidth. So let's just jump over to a Category 6A test and notice we're using the plus PoE limits here. So we're going to test not only will this support 10 gigabits, but also is it designed to properly support those high power applications? And there we go. It's passing. One thing of interest, about 40 meters of cable, you may not have noticed the other one had 50 meters of cable and 25 ohms of resistance. Here we have 40 meters of cable and only 4 ohms of resistance. So we can see that this is a much better conductor, and this is going to be in a much better situation to support our power. All right, so we know that the cable is good. We know that it should be ready to support power over Ethernet. What are the simple things that get in the way of not supporting power over Ethernet? Well, the simplest thing is I'm not connected to a switch. Let's see if there's a switch on the other end of this link. There is a switch, but this switch is not offering power over Ethernet. I'm using the microscanner PoE, and it's asking the switch, what speeds can you do? Hey, I can do 10 gigabits, but I'm not offering power. So there's our problem. We have good cable, but the switch port is wrong. So we can use the MSPoE to look at the configuration of the switch port. Hey, this one has PoE. Let's jump in there and see how the switch is configured. And this is in real time, bear with me, but we can see that this is telling us that it's offering class 4. So is the port of the switch properly configured? If you want to have an arm at the end of your driveway that stops you from going out that's powered over power over Ethernet, Mark, that is not the one I would have picked. We can see that the switch would need to tell us that it's offering us more power to support that arm. This one is configured to support class 4. So in summary, make sure you add those plus PoE limits to your tests to make sure that your cabling is going to be ready to support power over Ethernet. We've seen, and frankly it's scary, this cable did pass a Category 5E test, but it's not ready to support power over Ethernet. And with that, let's jump out and see if there are any questions. Mark, any questions came up?
Here's one question that showed up is why would you use the plus PoE tests and not the plus all tests? Jim?
That's a fair question. And it depends on what your environment is and what your testing is that you have to do. Really, it's just a time issue. It takes a little bit longer to run the plus all tests. Well, what the heck, let's run a plus all test here. So it takes a little bit longer to run the plus all tests. The plus all tests are going to really whoa, that's not what we want. The plus all tests are really going to stress the capabilities of the tester. They are going to go all the way to the limit, not just of the standard signal and noise, but some extended tests that we're capable of running, like the balance tests, TCL, TCL on the far end, ELTCTL, and then some other common mode tests, like common mode next and common mode return loss. Most end user customers in their cabling specification we will be lucky if they ask you to test against the 568 limits. The plus PoE is an important step forward. I find that it might be a challenge to explain that we also need to run these TCL and ELTCTL tests. What happens if you fail them? So please run plus all, but at a minimum, let's try for plus PoE. Good question.
Jim, I'll also point out that it's my understanding that the TCL and the ELTCTL, it's a mouthful.
Equal level transverse conversion transfer loss?
Yes, I'm not even going to attempt that. But those are important in noisy environments, and those are tests that if you're in say an industrial environment, like in a plant where there are a lot of noise sources, those are things that can be considered. And I believe there are some standard tests for industrial cabling that do include those tests.
Absolutely. If you're in an industrial environment, there are different levels of TCL tests. I'm going to just edit this test we just configured. And if we go back to more and TIA, I'm actually just going to look at Cat 6 here for kicks, and we scroll all the way down, you'll see that we start to get into the TIA 1005. TIA 1005 is the 568 common standard applied to an industrial environment. Typically, we use the 568 for commercial buildings, but if you're in an industrial environment, they have a MICE rating table that describes different levels of severity of the environment. An E1 environment would be an office, something with carpeting. E2 would be light industrial, and E3 would be heavy industrial. This is the most difficult test that we could be doing, but it shows that the cable has excellent noise immunity when you're in those noisy industrial environments.
Thank you, Jim. Another question that's come up is, do we recommend, or are there any advantages to using Cat 6A over Cat 5E when you're running for PoE or running PoE?
Anyone else want to jump on that one?
Yeah, I'll definitely jump in on that one because I actually got my hand slapped by a standards body for making a comment that Cat 6 didn't really have an application, and that turns out not to be true. So Cat 6, generally speaking, is 23 gauge cable. Cat 5e cable, generally speaking, is 24 gauge cable. So that 23 gauge, you got an extra bit of copper, that's going to reduce your overall resistance and theoretically would do a better job at supporting the high power PoE. So there is an argument now that if you intend to install PoE, go and select a 23 gauge cable. Now what's really interesting about this is I just said, generally speaking, Cat 5e cable is 24 gauge. As a result of that, manufacturers are starting to offer Cat 5e cable that is also 23 gauge, because you may not need the performance associated with Cat 6. You just want the ability to transmit power. So now there are a number of specific Cat 5e cables which are 23 gauge, which are targeting that. There are also some 22 gauge cables out there as well. Again, adding more copper in, reducing that resistance, less resistance, less heat in the cable. Now, that's another thing we didn't talk today about is the bundling of cables and heat. If you have a 22 gauge versus a 24 gauge, there is going to be less heat buildup in that cable. And then, of course, if we're talking about heat, then you're on to the UTP versus FTP cables, and it is generally accepted that FTP cables are a lot better at dissipating heat. But when you start talking FTP cables, you're now talking about a shield and dealing with that shield, and that's a topic for another day, I think.
Thanks, Adrian. You answered 3 or 4 questions there with that, so we certainly appreciate it. The questions about shielding and 6A as well. So thank you for that. Let's see. There's another question that's come up. It's asking about what are the different PoE power levels. Jim, you demonstrated a class 4 power, but what are the different power levels and what are their parameters? Are there limits on length or the amount of power or anything like that?
Are you going to answer that question yourself?
I'll answer it if you'd like.
Yeah.
Actually, I wish I had a table handy.
I'm looking for it.
Okay, thank you. If you can pop it up, that would be great. There are 8, or sometimes some people say 9 different classes of PoE power, each one having their own amounts of power, which I can't come up with off the top of my head. I know that class 8 is 90 watts at the source, and I think it's guaranteed 72 watts at the far end of the cable. All PoE is designed to work over a full 100-meter run, which would be a 100-meter channel, as long as the cable meets the standards. Oh, thank you very much, Tim. So you can see there, I was off by 0.7 of a watt for my class 8. But anyway, you can see that the different classes of power. And one of the things that's going on today is that the Ethernet Alliance, which is a group of companies that support Ethernet, and we're also a member of it, are trying to get people to think in terms of these different classes. Now, why do you want to do that? Well, it's very hard to remember exactly, well, how much power is sourced versus how much power is delivered to the powered device at the far end. So for example, with class 6, the switch puts out 60 watts, but they will only guarantee that 51 watts will make it to the far end. So if I've got a device and I'm trying to figure out what's the source amount of power and the required amount of power, the idea is to just have these simple classes. So if I have a switch that tells me it does class 6, I don't have to worry how many watts it is. I will just look at, say, my camera or my parking lot actuator arm or display, and if it says it needs class 6 power, then it's simple. I'm done. It's really easy. I don't have to compare exact power levels. I don't have to worry about which pairs it's on or anything else. If it says class 6 on the switch and it says class 6 on the device, I'm good. If it says class 7 on the device and it says class 6 on the switch or on the microscanner, it's not going to work. And of course, if the number on the device is lower than what you read on the microscanner or the switch. So for example, a class 2 device will work fine on a class 6 port. So those are the different amounts, but you don't have to worry about, what's the length of the cable or anything else. The one thing you should worry about, though, is running the PoE tests, as we talked about before, because it's possible for a device to pass, it's possible for a link to pass, say, a category 5E or a category 6A, but still have resistance problems, which could be the fault of the cable, or it could be a faulty punch down or a bad connector. And you really want to get that extra level of confidence to make sure. Because the other thing that happens with PoE that you should worry about is it may work intermittently. So if the resistance is a little bit too high, it might work well on a cold day, but on a hot day, it then might start cutting in and out. If you run the tests with the PoE, you'll know that you've got the extra margin and things will work well. So, anyone want to add to that?
No. Excellent. Excellent. Everyone's participating today.
All right. Thank you.
No, I would just say I don't think my HOA, my homeowners association, actually allows barriers on my front driveway, but I'll check with the documents.
You'll check into it. Hey, Jim, if you want to show that last slide, that is something this is late breaking news, like within the past week and a half, is that the Ethernet Alliance is announcing their program for certifying equipment. And you're going to start seeing, as of next month, you're going to start seeing devices out on the market that either are power sourcing equipment, such as a switch, or a powered device, such as an access point or a camera, that will tell you that they are certified and will also include the class number. So this makes it very easy to just look at the back of your camera, look at the front of your switch, and if the numbers are okay, then you're good to go. And so over the next 6 months, this won't work. Something putting out 3 will not drive something that's looking for class 4. So over the next 6 months, you'll start seeing more and more devices on the market that will have this. And this is really going to simplify being able to connect things together and know they're going to work. Because not only do they measure the power level, they actually verify and certify that the device meets all of the IEEE PoE requirements. So you don't have to worry about whether or not it will work with with IEEE compliant devices.
Yeah, interoperability would be a key feature there.
Yes. Okay, I think we answered all the questions that have come up. So Jim, you want to throw the website up there just so we can wrap up with that? So as you know, we are running these webcasts about every week, and we certainly appreciate your attention. If you go to our website and you want to check out what's coming up next, you can go down to the bottom, but Jim, it's a lot easier if you go to the top.
Hey, who's driving here?
If you look under training and events, you'll see our web seminars, and you'll see we've got a couple more coming up in the next few weeks. We are running a program where if you attend 4 events in June and July, you'll be entered to win the microscanner PoE, which Jim just demonstrated to you. So if you're interested in winning one of those and you want to learn more, jump on over to our website, sign up for a couple of events, well, 4, and there will be more coming. We've got more in the planning stages right now after the end of June. We might take the week of July 4th off, but we've got more coming up in July as well, and especially some exciting new announcements. So stay tuned, check this webpage, watch your emails. We'll also let you know by email if you're one of our subscribers. And with that, thank you to Jim and Adrian for helping out today. And have a great day, everyone.